Hello, welcome to this video. Today we're doing something different. We're gonna build a cube out of these parts and then finding formulas that will tell us how many different parts we need to build the cube. So these are the three different parts we have. We have this long line piece, this short line piece, and this ball, and they come together like this using the power of magnetism. And they connect like this. And now let's actually go and build the cube. So as you can see, we have the cube, but we still have some parts left. So I'll move those to the side and we'll go on with what we originally wanted to do. Our goal, to find a formula for how many parts you need to build this cube, and more specifically, the formula for how many you need for each part. So, a formula for how many balls you need, how many short line pieces you need, and for how many long line pieces you need. So before we actually start calculating, let me say the rules for the cube. And the rules for the cube are very simple. As you can see, how these balls and the short line pieces form the actual cube. Then with the long line pieces are the diagonals of each 1 by 1 square we have in this cube. There is no 1 by 1 square we have that doesn't have this diagonal. There's only one. You can't fit two. And there is no diagonal for any of the cubes, 1 by 1 by 1 cubes, so we don't have to worry about that. And now let's calculate. Alright, now we're actually going to find the formulas for this cube. So I'm going to start the easiest and work my way up. So, the easiest ones are the magnetic balls. So, let's do them first. It's pretty easy. But actually, before that, what to address. This is generally for an n by n by n cube. I already said the rules of the cube in the past. And my definition of the side length in units being n is you need n, these short line pieces, to construct one of these big line pieces of the actual cube. So now, out of the way, let's actually do it. So, because there are n short line pieces on the side of the cube, we have n plus 1 of these magnetic balls. Meaning that we can split this cube up into n plus 1 layers and then the amount of balls in each one. Adding it up, we'll get the entire amount of the balls in the cube. And since we have n plus 1 balls on the side, we have n plus 1 layers. Meaning that we'll find out how many balls are in each layer, and then we'll multiply by n plus 1. Since the amount of balls in each layer is the same because of the symmetry. So, let's see. Look at this layer. And we'll break this layer. Since on the side it has n plus 1 balls, we can break it into n plus 1 of these lines. Meaning that we'll find just how many balls are in each line, then multiply by n plus 1 amount of lines, and then multiply by n plus 1 again, the amount of layers, giving the total amount of the balls. So, let's see. We know how many are on each line on the side, n plus 1. So, like I said, then multiply by n plus 1 amount of lines, again by n plus 1 amount of layers, that gives us the total amount of the balls. So, we'll have n plus 1 times n plus 1 times n plus 1, which is n plus 1 cubed. So keep in mind that is for the balls. Now we'll do the next one. And actually before you do that, so you don't forget, I'll actually write down that this is for the ball. That's okay. So that's for the ball. Sorry for my handwriting. So now we'll do the long line pieces, which are the next one on the hard level, though they are still pretty easy. So by our definition of the cube, each one of those 1 by 1 squares has a long line piece, meaning that if we say want to find how many are in each one of these like layers, we'll find out how many 1 by 1 squares there are, and we'll do it by area. So since the 1 by 1 squares cover it perfectly, well, the area of the 1 by 1 square is 1 unit squared. And then we'll do the area of the actual layer, which is an n by n square, giving us an area of n squared unit squares, and then divide that by our 1 unit squares, meaning that we have n squared 1 by 1 squares in each layer, meaning that we have n squared line pieces in each layer. And then we have n plus 1 of these layers, so n plus 1 times n squared. But then we have 3 directions that the layers can go. So there's this, this, and this. This, and that. Meaning that we have 3 total directions because of the symmetry, they're all the same. So we multiply 3 and n plus 1 by our number of n squared. So for the long line piece, I'll just write long. We have 3 times n squared times n plus 1. And now, for the short ones, which I think are the hardest, the similar thing with the balls and the long line pieces. So, let's see. 3 directions it can go. So, this one, and this one. So 3 times how many have in just one direction. In each direction we have n plus 1 layers. So 3 times n plus 1 times how many we have in each layer. In each layer, we'll break it down into n plus 1 of these lines. So 3 times n plus 1 times n plus 1. And then how many do we have on each of these lines? And the definition is n. So n times n plus 1 times n plus 1 times 3. Meaning that for the short, we have 3 times n plus 1, which is 3n times n plus 1 squared. And that was our goal, finding how many parts we need for each one. And that's it. If you want more content like this, please subscribe to my channel. I'll have more interesting stuff like this in the future. Finally, that is it.